Okay, this last part of 6.3, we're going to talk about simple or special solutions. The different kind of solutions we can get when solving a system of equations is a one solution situation, and that's where we're left with a point x, y, a one-point intersection. And if you look here at this example, this visual example, we have an intersection point. A no solution, keeping in mind that as solving a system of equations means find where they intersect. Well, if there's no solution, that means they never intersect, which means if you look at this visual, that they are parallel lines. And when we talk about no solutions, if we can recall back to when we've solved other special situations, you get a false statement when you go through and solve. So you'll get something like a 0 equals 5, or 0 equals negative 10, or maybe you'll get a 1 is equal to 35. You'll get something that's false. An infinite solution, what it really means, again, keeping in mind that we're solving systems of equations, and a system of equation means when we solve, where do they intersect? Well, if I say that they intersect for infinity, they always intersect, that means they are the same line. And when I say same line, what we really realize is one is a multiple of the other. One line is a multiple of the other. And so they'd really be lying on the same line. So when we think about a solution to a system, and I say if the solution is infinite, that means they always intersect. They intersect at all of these points, the whole entire line, and it will go to infinity. All right, one of the concepts that you'll be asked to identify is how many solutions there are to a system. So I'm going to have you just solve it the normal way. If I have 2x plus y is 5 and 2x plus y is 1, I'm going to go ahead and just cancel out my x by changing the sign. Again, I want them to be the opposites of each other. So this turns into negative 2x minus y is negative 5. And then I have the positive 2x plus y is 1. If I were to combine these, the x's cancel out, the y's cancel out, so I'm left with 0 is equal to 4. This is false. It's not true. So I say it's a no solution. And when I think about what does no solution mean with a system of equations, it means the lines are parallel. They are never going to intersect. Let's see what our little example has here. Yep, they have parallel lines. You see the green and the red line. They're parallel. They are never, ever, ever going to intersect. Okay, moving to the next example. I have negative 2x plus y is equal to 3. I want to solve this system my normal way. So I look at it and I think, what variable do I want to cancel? I usually cancel the first one. It really doesn't matter. Some of you like to cancel out the y's. Some of you like to cancel out the x. It's no big deal. As long as we will all get to the same answer. I'm going to times through by a negative 2. The reason I chose negative 2 is because I will get a positive 4x as I distribute. And the 4x and negative 4x will end up canceling out. Okay, distributing, I get positive 4x minus 2y is equal to a negative 6. Rewriting the bottom equation, I am not doing anything different. Combine. The x's cancel. The y's cancel. The negative 6 and 6 cancel, so I'm left with this. A 0 equals 0. So that tells me that this is an infinite solution. And when I say infinite solution, again, we're talking about a system of equations. That means where do they intersect? If they intersect for infinity, that means they are the same line. Let's see our visual here. If you look, and they just drew one color, but really you have the line right on top of the other line. All right, next example. Determine how many solutions there are to this system of equations. Looking at these, I want to try to cancel out my x or my y's. I see my i's go right away to this plus y and minus 3y. So I see I wouldn't have to distribute a negative at all. So I'm just going to times this top equation by 3. Distribute. 9x plus 3y is negative 3. Rewrite the bottom. 9x minus 3y is 3. Combine. 9x plus another 9x is 18x. The y's cancel is equal to negative 3 plus 3 is 0. This term x then must be 0. So this is going to be a one solution. Notice I can tell that because my x didn't cancel. You're going to get a no solution or an infinite solution when both of the variables cancel out. Now I look here, I got to find my y. So I kind of box off my x. I'm trying to put my eyes, where is that x going to go? My strategy, I put it right, whoops, it's the x. I put it right back to the original equation. All right, and that turns into 3 times 0 plus y is equal to a negative 1. Y is equal to a negative 1. So my point of intersection is 0, negative 1. This is a one solution system. And then there you can see I got 0, negative 1 as my solution to this system. All right, I'm going to do this next one with you, determining how many solutions there are here. I'm looking, and I see that I have a negative 2x and then a positive x. So I'm going to turn this, I'm going to get a 2 out in front. I cancel out my x. And I get 2x minus 4y is 10. Negative 2x plus 4y is 2. Okay, I'm going to combine. The x's cancel. The y's cancel. So I have 0 is equal to a 12. That is false. So this is a no solution. And when we're talking about systems, again, no solution means they are parallel lines. Okay, they are parallel lines. And I can tell right away the biggest thing that 8th graders struggle with is once I start showing them things like this, they always think that you're either going to have a no solution or infinite. But you can always tell because you go through the normal strategy and then you end up with something like this where the variables totally cancel out. Looking here, here's our visual. I can tell that these are two parallel lines, so they are never, ever, ever going to intersect. All right, determining how many solutions this next one has. I see that I could either times through by negative 2, the top one, or I could times through by positive 2 and get rid of the y. The negative 2 would get rid of the x. The positive 2 would get rid of the y. I don't really care which one I'm going to choose. So I will times through by negative 2, only because I like to get rid of the x. Be careful though, because a lot of people struggle and will want to make some kind of sign error as you distribute through that negative. So you want to make sure if you're going to distribute through a negative, you might want to just choose another variable where you don't have to distribute a negative. There's nothing worse than going through all that work and you made some small error that leads you to the wrong answer. Go through and combine. My x's cancel. I get a negative 4y is equal to a negative 8. So my y is a 2. Oh, this tells me my variables didn't totally cancel out, so this tells me this is a 1 solution. I box off my y. I look to see where my other y is, and I bring this over to it. And I get 2x plus my y, but my y is 2, is equal to 4. 2x plus 2 is 4. 2x is 2. X is 1. So this is a 1 solution, and my point of intersection is at the point 1, 2. And here we can tell that we intersect right here at this point 1, 2. So, just to summarize, we have 3 possibilities for linear systems. We have a 1 solution, that's where we get an x and a y. We have a no solution, we get a false statement. And that tells us that we have parallel lines. And we have an infinite solution, which we get a true statement. And when it's a true statement, it really is the same line. Keeping in mind that systems represent a point of intersection, and if it's a false statement, that means that they're parallel, they never intersect. And if it's an infinite solution, that means it's the same line, that means they always intersect. So those are the 3 different types of systems that you will be exposed to.